Welcome back, ladies and gentlemen. Still on our first unit in Introduction to Geography, but we're going to shift gears. Now we're going to look at some processes that actually affect the Earth itself. And the item that we're going to look at today is the sun and the impact that the sun has on our Earth. So our first term to look at is solar energy. So we're talking about energy from the sun. And the amount of solar energy on Earth is affected by four things. And that's Earth's rotation, its revolution, the Earth's tilt, and our latitude. So we're going to look at how the Earth moves. And there's two main ways how the Earth moves. The Earth rotates and the Earth revolves. So we'll take a look at what each of these ways move like. So the rotation of the Earth, as we're rotating, we're spinning. So the Earth spinning on its axis is its rotation. And this rotation is what causes day and night. And it takes about 24 hours, one day, for the Earth to make one full rotation on its axis. The revolution of the Earth, this is our year. A revolution is the time it takes the Earth to go the whole way around the sun. So one revolution takes 365 and 1/4 days. Well, we cannot have just 1/4 of a day, so that's why every 4 years we add February 29th to the calendar and we create leap day for that year. So the Earth, as it travels around the sun in its revolution, we call the path that it takes its orbit. And that orbit takes 1 year, or 365 and 1/4 days, to complete. We also said that the tilt of the Earth affects how much solar energy parts of the Earth receive. The Earth is not just sitting straight up and down. The Earth is tilted at an angle of 23.5 degrees. And that 23.5 degree angle plays a very important role that we'll see in a future slide. So the places tilted towards the sun, those are the places that get more energy. So in this image right here, you can see if this is the sun, the southern part of the Earth, the southern part of the Earth would be getting more of the sun's energy because it's the side of the Earth that's tilted towards it. So it's going to have warmer temperatures. The areas that are tilted away have the cooler temperatures. They're not receiving as much energy from the sun. Another thing that affects Earth's solar energy is latitude. Latitude is that distance north and south of the equator. Most of the sun's energy is focused around the equator because it bulges out at that point. The further you go, either north or south, away from the equator, the colder the temperatures get because the sun's not sending as many direct rays to those areas. So the Earth is receiving less direct rays the further you get from the equator. The less solar rays that you get, the cooler or colder the temperatures get in those areas. And then we said, what causes the seasons? The tilt of the Earth. The tilt of the Earth is why we have 4 distinct seasons on the Earth. Not every area on Earth has 4 distinct seasons. If you're near the equator, you have warm temperatures year-round. If you're near the North or South Pole, you have the cold temperatures year-round. But those middle latitudes, such as Pennsylvania where we live, we have those 4 distinct seasons. And we have those because the Earth is tilted. And the reason being is only one hemisphere, northern or southern, can be tilted towards the Earth at once. So if the northern hemisphere is the hemisphere that's tilted towards the sun's direct rays are focused in the northern hemisphere. So the northern hemisphere is getting the warmer solar energy. So if it's summer in the northern hemisphere, where this direct energy is hitting, the southern hemisphere is pointed away from the sun. It's not getting the solar rays. So they're going to have the opposite season and the opposite energy than the northern hemisphere. So the seasons in the northern and southern hemisphere are opposite. When it's summer in the northern hemisphere, it's winter in the southern hemisphere, and vice versa. When it's winter in the northern hemisphere, it's summer in the southern hemisphere. And then spring and fall are opposite as well. And that is because you can only have one of the hemispheres tilted towards the sun at a time, receiving the Earth's solar energy, or receiving the sun's solar energy. So, at this point, go ahead and make sure you're reading everything else that there is to do in Google Classroom for today's assignment, and we'll see you next time.